All right, I'll just hand it over to you and you can start. Go ahead.
Perfect, thank you. Welcome to another presentation of our fraud risk management solution, Actio, that we are building adjacent to a Mojaloop implementation. This is, I think, my 8th convening overall. So this has been a long journey for us to get to this point, and it's a really exciting presentation for us as well. So I'm going to jump right in from just a little bit of background. I know there must be some people in the audience who are new. So just to recap on how we got to where we are. Slowly, first slide. We started our journey towards building an actual product with a POC where we proofed some of our initial hypotheses around performance and the capability of a platform to run topologies and a rules-based evaluation system over transactions attached to Mojaloop data. That was deemed successful enough for us to continue working on the actual product. And over the last year, we have made major strides in building a transaction monitoring solution that could be attached to a Mojaloop platform and intercept Mojaloop data, evaluate that data for a variety of money laundering and fraud typologies, and then ultimately submit a result. Just tap for the next set. In our last 2 PIs, our previous PI was largely consumed with securitization of the platform and completing our end-to-end flow. So this PI for us was a focus on what we call content. Content involves the finalization of all of the message types that we expect to receive from a Mojaloop instance in ISO 20022 format. And also, we started to build out a variety of rules and typologies. So we had, for the purposes of our presentation today, established 2 typologies consisting of 9 rules that we could take you through. And then there were some minor gaps in the end-to-end flow. So as we went through, we discovered a couple of things that were new to us or had emerged during the last PI. So we closed those as well. From a context perspective, the transaction monitoring service is a solution that sits adjacent to a Mojaloop instance and intercepts the transactions from a Mojaloop instance. We also allow the capability for somebody like a DFSP to also submit their transactions to the platform. The reason for that was the semi-attached architecture that we selected. The semi-attached architecture allows a fraud risk management solution to also receive those transactions from a DFSP that the hub would be blind to. So where a DFSP has point-to-point arrangements with other DFSPs or perhaps internal transactions that aren't routed through the hub, we want to create an opportunity for those DFSPs to also send their transactions to the fraud risk management solution so that we can get a complete picture of the transaction. The solution in its MVP state is built as a back-end solution. So you send us data and we send you a JSON alert that contains all of the information that we had discovered about the transaction that you had sent us. In future revisions, we expect that there would be some kind of user interface overlaying the entire platform. And also you would be able to attach case management, analytics, and investigation tools to the message that we distribute from the platform on fraud alerts. Next slide, please. Our overall process flow. So we anticipate that the platform will be prefaced by some sort of payment platform adapter, in particular to accommodate Mojaloop in its current form. I know Mojaloop is moving towards an ISO 20022 messaging format in its ingress and egress, but at the moment it still speaks Mojaloop. So we have built our TMS API in ISO 20022. So we can then convert that message through a payment platform adapter into a ISO 20022 message. We do our upfront validation against ISO standards, and then we submit it into a data preparation stage where we can do our pseudonymization to protect personally identifiable customer information, and also to create our transaction history that sets us up for the rules evaluation later. The next step in the process is what we call the channel router and setup processor, where we almost arbitrate the rules and typologies that we want to invoke for a given transaction. We analyze the transaction and we pick the rules that we want so that we don't have to execute every rule in the platform and waste resources doing work for nothing. Then there's the rules. So every rule is executed then once, and those rule results are aggregated by a variety of typologies, a typology being the recipe for how fraud is conducted. So the rules effectively identify the fraud, and the composition of all of those rules into a typology will tell you what kind of fraud you're likely seeing in the transaction at the time. Beyond the typology processor, we start collapsing back all of the variety of rules and the typologies into what we call themed channel results. So those could be money laundering channels, there could be fraud channels, there could be high priority, high resource channels for high speed if you wanted to do something that we call interdiction. And then after that, right at the end, we generate a transaction result that is a fully unabridged JSON file that contains all of the information that we had compiled about the transaction to date. And we send that through to a case management solution. Case management solution currently isn't attached to the fraud risk management platform, but our egress does allow for a case management solution to pick up that message when it arrives. And that overall is the end-to-end flow of the platform, and that's what we have built and finalized over the last PI. I just want to quickly give you an overview of, just as a highlight, the features that we have built in our PI 5. So if we look at the next slide, we did quite a bit of work. So we have updated our API now to include all 4 of the ISO messages. We are pseudonymizing all of the debtor and creditor account information in all of those relevant messages, with the exception of the PAC 002 message that doesn't actually contain any account information. It's mostly just a status message that responds to the PAC 008 message. And then we have also updated a transaction graph with all of the flows for all of the messages. So between the debtors and the creditors that are identified in each of those messages, we can now build an extensive transaction network graph that supports some of the rules that we use to make those rules more efficient. We also create a transaction history, unabridged, in almost a traditional blob storage or relational database format. And then we implemented our compact JSON ISO 20022 message format end-to-end across all of our processors so that they all speak the same language. We've implemented semantic versioning for all of our processors. We were 1 digit short of full semantic versioning in our prior release. So for this PI, we have now extended it to full minor, major, and patch versioning. And we are now triggering evaluations on the transaction conclusion instead of the initiation. Initially, we used the pane 001 message for our transaction evaluation, mostly because that was the first message that we expected to receive. And while we were developing, that was the one we had at hand. Now that all of the messages are in the platform, we can actually use the message that concludes the transaction flow. If you wanted to build interdiction into the platform, you would obviously want to use the pane 001 message to trigger those evaluations, because then you can get your result as soon as possible, and then also generate an alert that might be able to interrupt that transaction. But for now, without interdiction, the PAC 002 message is sufficient for our needs. We have consistently formatted the processor results so that at the end, we generate a consistent and meaningful result that is a combination of all of the processor results in a consistent language. And we are now also generating that investigation alert as an unabridged JSON message that egresses from our system. We had set up a dummy API to capture that API message at the end of the process. And also we had done the white source security scanning with the support of Godfrey and his team. Given a lot of work that we had put into our securitization of the platform in the previous PI, we're actually quite happy with the outcome of that. Didn't turn up anything alarming, and it seems that we have quite a stable and robust platform in play at the moment. And as I mentioned, we built those 2 typologies and the 9 rules. I'm happy to have made it through this part of the presentation in my allotted 10 minutes. I think I'm doing well. So on the next slide, what we're going to do now is something they say you should never do live, and certainly not in front of an audience. We are going to show you a live demo of the platform in action. I'm going to hand over to Foley now. We have recorded this earlier as a plan B, just in case something does go wrong, but we are hoping that nothing will. So strap in and over to Foley. Take us through the platform. Thank you.
Right, thanks, Justus. So let's show what you have just presented. And to start off, what we'll show is the CI/CD pipeline. I'll show everything that we've got set up in our Jenkins. The first one would be to deploy the entire system from all of the different prerequisite frameworks that we require, as well as all of our different processes. I'll briefly touch on the security. We've showed that previously. And then the last one would be the testing Jenkins job that we've got set up with all of the different tests. So firstly, the security. So in the security, this is just all the snipe and gripe scans and so forth that we've got set up to be able to run them again in the future and often as and when required. And then after that, the deployment of the entire environment. So we can see that it starts by deploying things like Redis, NiFi, Grafana, Prometheus, and so forth, all of the different tools that we require. And then it ends off with deploying all of the different processes that actually makes up the fraud risk management system. This entire deployment usually runs around 47 seconds to deploy each of all of these processes to our Kubernetes clusters. After that, inside of our testing piece, we'll see that there are many different tests for each of the different processes that we write and the rules and the topologies. It is a testing or a development environment, so we do expect some red ones to fail along the way. But the one I want to focus on is the parallel pipeline that runs on every build. That could run on every build that would ensure that all of the different processes are actually working and in a good state before we carry on to actually deploy that code. So that is our parallel pipeline that's testing each of the components individually. So after this, I want to start the actual demo to show how a transaction would flow through the system. I'd use the trusty tool called Postman. I will just focus on the transaction monitoring service from here and mention that it supports the 4 different ISO messages, SPAN 01, 13, 8, and 2 packs, which correlates to the 4 different modular loop messages, SPAN 01 being post quotes, 13 being the corresponding put quotes, packs 08 and packs 02 for post and put transfer. In a normal environment or in the production environment, the flow of messages would first be from pane and then packs and then packs 02, packs 02 being the final message transfer confirmation. For this demo, we've set up so that the rest of the messages has already been sent, and we'll just go ahead and send the put transfer, or in our case, the packs 02 message. So if we do go ahead and submit this transaction, what this will now go and do is, after the transaction monitoring service has validated that this message is a valid ISO message, it would actually accept this message and say that it is a valid message. After it's then done that, it would then go over to the NiFi flow, or the data preparation flow. In data preparation, it would route the transaction for one of the 4 different message types that it is. Based on the different message types, it will do something different. For most of them, we'll see that there is a step for data enrichment right at the start, where we can add any additional information to the transaction that it might not have. After that's done, it will then go over to pseudonymize all of the information in the entire message. This is to remove any customer information so that in the rest of the platform, we don't have any customer specific information. And that message is then pseudonymized. After that, we go over to inserting the transaction history, where we insert an abridged original message, and we also populate a transaction graph that has all of the customers and the transactions between the customers as edges. For the packs 02 message, we'll see that it doesn't actually do the data prep and pseudonymization steps. The reason being that the packs 02 message doesn't have any customer information, as it's basically a shell message with basically just the final confirmation of the transaction. After it reaches NiFi, from NiFi, it will then go to the channel router and setup processor, or CRISP for short. Now in the CRISP, if I just go over to APM, the rest of the processing we will show with our application performance monitoring. So we've got APM set up for all of the different processes, and we will then take the rest of the demo in this view where we can see the application performance monitoring and how it went through all the different processes. Justus, over to you.
So the channel router is setup and processor. What we had previously discussed is what it does is it evaluates the contents of the transaction, and then on the contents makes a decision about which rules and topologies to invoke based on the attributes of the transaction, and also in combination with a pre-configured network map that has the entire route of the platform laid out. All of the channels that you would like to use, all of the topologies, all of the rules, all of the variety of transactions, and also as a future enhancement, the attributes and some logic about which decisions and routing decisions to make will also be contained in the network map. The rules are composed into topologies, which are sorted into channels. The channels are according to a variety of customizable themes. Themes that we can immediately think of the top of our head are fraud themes or money laundering themes or high priority, high speed themes for interdiction and so on. The pane 001, 013, and pack 008 messages all terminate at the crisp at this point because there are no downstream rules set up to evaluate those components of the end-to-end transaction flows. If you wanted to implement interdiction, you would update a network map that could pick up the pane 001 transaction and then route it into a high-speed, highly resourced channel where a decision could be very quickly made that could then respond to say that there is a risk that this transaction is fraudulent and gives the client system an opportunity to then block that transaction. Let's have a look, Folio, at how those rule processors work.
Right, so when the CRISP receives the message, the first thing it would do is it would actually read the current actively configured network map. It would then take that network map and determine which rules are applicable for this transaction based on attributes inside of that transaction. It would then deduplicate all the rules so that we send the request from the CRISP to the rule processor for every rule only once. After that, we will remove all of the configuration from the network map that is not required for this transaction. After that, it would send that network submap on to each of the rules only once. As we are following a forward chaining microservice architecture, each of our processes would forward that network submap on to the next microservice so that each of them then knows where to find the next processor in the chain. Joseph, will you tell us what those rules and topologies actually look like?
So for the purposes of our demo, we'd actually structured two topologies. We picked a topology 11, which is our traditional account muling archetype. And we also created a topology 28, which we call a scam topology. Account muling is behavior where somebody uses almost like a dummy account and money is routed in and out of that account for either money that was stolen from clients or in scams or accounts that had been taken over, or perhaps even just to defray money into a criminal network for money laundering purposes. So you'd want to be able to identify those accounts in your network. From a scam perspective, people who are falling victim or about to fall victim to the romance scams or advanced fee fraud or lottery scams, perhaps, we have a topology set up with a number of rules that can evaluate that. We picked our topology 11 for our audience to walk through today, and we gave just a short list of the rules that we had implemented so far to evaluate that topology. And in particular, we are still working on more rules. The more rules you have, the better your ability to discriminate the fraud that you are seeing, and also to minimize false positive results at the end of the day. Here we are looking at things, for example, like how old is the account that you are paying money into? And we have to, at the moment, derive that information by polling transaction history, particularly because the creditor's account opening date isn't actually part of our data that we are currently receiving. In the absence of that information, we model the account age. We also look at how long has that account perhaps been lying fallow without any transactions coming in or out of that account. Sometimes, to get around rule number one, a fraudster would set up an account a long time in the past and then leave that account and wait for it for the right moment to use it for a muling account, for example. We look at things like transaction divergence, where how many transactions are being paid from the debtor's account in a very short space of time. We also look at things like transaction mirroring. Mirroring being where a transaction arrives in an account and almost immediately leaves the account again as it's being paid forward to a different creditor. There are a variety of different flavors of mirroring. You could even see aggregated mirroring, where a number of incoming transactions are batched up, and then one bulk transaction leaves, or a number of smaller transactions leaves, but more or less to the same overarching value. And then you can also get a withholding of commission in that structure. So we have a rule that evaluates immediate transaction mirroring in our topology. And then we also look at things like, is this the first time that the debtor is paying someone? Is this the first time that the creditor is receiving money? As a sample of the kind of rules that you would expect to execute in order to evaluate whether the account is a muling account. Let's look at one of those rules.
Okay, so after the CRISP has executed a rule, we'll see that there are a couple of different ones that it has executed. I will go into detail for rule 27, or the immediate transaction mirroring rule. So in this rule, what it does when it gets executed is it would go and find all of its configuration and all of the historical data that it might need. And if it has all the information to be able to determine if this was immediate transaction mirroring or not, then it would send its outcome off to the topology processor.
The specific results of a rule has a predetermined scoring impact on a topology's overall score, which is why we send the rule result over to the topology. For example, the rule can evaluate to an immediate transaction mirroring has 6 predefined outcomes, and in the topology configuration for that rule, we allocate scoring values to those outcomes, and then we define how those scores impact the topology score at the end of the day and check against the threshold if that topology triggers. The topology processor introduces an interdiction opportunity at this point as well. So if any single topology breaches its thresholds, it can immediately flag the transaction for either review or to block the transaction.
So if we then look at what the topology processor does, is it would receive the request from the rule processor, find the topology configuration, and then handle that request accordingly. If it realizes that it hasn't received all of the rules, the results that it is expecting, it would save that topology interim results to cache. This is being done because we have a fully scalable and stateless microservice architecture. So that means that the topology processor that has received this rule request might not be the topology processor that eventually evaluates this transaction and sends it off to the channel router, channel aggregator. So that is the reason for this interim results cache. What would happen is, as the different rules start to finish and send their request off to the topology processor, the following topology processor would keep on reading the topology cache, and then up to a point where it's realized it has received all of the different rules results. As soon as that happens, it would then send the request off from the topology processor to the channel aggregation and decision processor, or the CAD proc. The CAD proc will very similarly wait for all of the different topologies to finish. If all of the topology results are received by the CAD proc, it would send the request, this transaction, off to the transaction aggregation and decision processor, or the TAD proc. The TAD proc will similarly wait for all the CAD proc processes or all the channels to finish. After all the channels are finished, the TAD proc would read the transaction configuration to figure out what to do with all of these topology results. It would then go through each topology and compare the topology's result and see if it has breached the configured threshold. If any of the topologies have breached the threshold, that means this transaction is most likely fraudulent and would need to be investigated. It would then, the TAD proc would then send that transaction off to the case management system from where an investigation could follow. That the TAD proc also saves the outcome of each transaction's outcome, no matter if it was fraudulent or not. So to go over what that request would look like, we've actually set up a case management sample endpoint. So in our logs, we can just see that our transaction aggregation and decision processor has actually send a request off to CMS and has received the status of 200. Right now, the CMS doesn't really do anything. It's more a simulation of the endpoint so that we can later on just update the network map, and this will then go to any live endpoint or any case management system. So what does this report look like? From the chat rock, we mentioned that we saved the final unabridged report of what we have done to this transaction. So in that report, we'll see the original transaction in the ISO format that it is in. We will also see the network map that was used to configure to determine fraud on this transaction, with all of the different channels and rules that is set up for this. As we mentioned, topology 11 and 28 was used in this case. And then I want to go in a bit of detail over all the results, or the channel results. So this is the outcome of all the different rules and topologies itself. So the first thing that we'll see is that there's one channel, and this channel has two topologies set up for it, and these two different and we can see that this channel has an outcome or a status of review, which means that one of the topologies or rules have actually been triggered. So if we then go over some detail over the topology that we can see was actually flagged, we can see that it has a result of 250 and its configured threshold was actually 100. So that means this topology is actually flagged for review. If we then go over to look at the different rules, we can see that the first rule has a result of true, and we can see that rule 3 has a result of true, reason being that the creditor account was not dormant in the last 3 months. And we can see that 16 is true, and the reason for that being that there was transaction convergence detected on the creditor account. So there's actually some additional transactions going to this account, which is unexpected. Then there's also an exceptionally large outgoing transfer detected for rule 18, which is a possible fraud, and so forth. So as we can see, it's very clear for a case management system for the reasons why this topology is flagged for review. And that concludes the end of the demo that we have today. So we would like to go over to a question and answer session.
There we go. Thank you very much, buddy. I'm incredibly proud of the work that the team has done over the last year. Looking at where we started with basically nothing, and we have a platform at the moment that can take in data and do a fraud risk analysis on that data and present a comprehensive and unabridged result at the end of the day that you could send to a case management solution, is an incredible achievement. And I just want to thank the team for the work that they've done over the last year. This is amazing. I'm incredibly proud of the work that we have done here. I'm going to stop gushing now, and then please, if anybody has any questions, ask now.
Justus, hi, this is Miller. Yeah, I have a couple, but first I agree with you. This is fantastic outcome. It's incredible to make this level of progress. Really great work. It seems that the process flow that leads up to the CMS would argue that the setup that this would be running in would be largely a backward-looking review system and not really established for immediate interdiction or for something where you'd be doing quick follow-up. And I'm wondering if you, and this is wondering out loud with you, in this particular example, you might think about how this goes from Innocent, we can hear you.
Some interference.
Innocent, we can hear you. FRMS, you might want to.
Miller, may I break your question up into 2 parts? Because I'd like to address
I wanted to get to the one question, which is, you go through this rule set here and you suspect that there is some mirroring going on with some intermediate accounts. What I would recommend is you might be looking at that as a set of compromised accounts along the path. Could those compromised accounts be triggered for PIN reset or 2-factor authentication? You might be able to interrupt the flow. It would be useful to see then, if you could interrupt the flow, could you then see if it in fact had an impact on the behavior, which would then give you an idea of what the related accounts were in fact being used for that. Obviously, you don't have an ability to generate that because you're not sitting at the mobile operator or at the bank account level to where you could do that. But is there a strategy within the CMS report outs that would suggest that kind of action? For instance, this account as flagged in Rule 72, might have been a compromised account, or there's a risk that it's a compromised account. Like how does the CMS integrate with the account hosting environment where obviously the action needs to be taken?
Miller, can I jump in there, Justus? Do you mind if I just a little bit on that? We do have the ability to do interdiction, provided that we do have access to do interdiction. But in the case that you're talking about for like a pin reset or something like that, the output wouldn't be to the CMS because everything's in channels. The output would probably be an 8583 message that goes to like a postilion switch that's running the card services, or some other switch that's running the card services that says there's a possible fraud, and then would lock that card, and then the normal processes would take effect. So, and Justus, I'll leave it the rest to you, but I'm actually working with that scenario at a customer at the moment.
So one of the things that we wanted to do with the end-to-end architecture is the architecture is supposed to be very flexible. We don't consider the ingress messages or the rules and typologies to actually be part of the platform. It's content that is being built into the platform for a very specific purpose, and that's to monitor the transactions. If we wanted to add additional data points to say, for example, we want to ingest customer lifecycle events into a separate data stream, then we can ingest those, pull them through our data preparation, and then feed them into a channel that specifically monitors customer lifecycle events, like a pin reset. And then it would, when a transaction comes through, it would be able to cross-reference prior behavior across any of those previous channels to say, there's a suspicious transaction coming through that is suspicious for these reasons as identified by the rules. And combined with that, we also know that that account had recently had a password reset, which then exacerbates or heightens the scrutiny that that account would then be subject to. And that's during the detection step. Beyond that, in the case management solution, you would have to be able to give the analysts access to a lot more data than the fraud platform itself has access to. So you would have to give them the ability to investigate beyond the scope of just the transaction that they're seeing now or the transaction history that we have. You'll have to give them access to information that may be protected by the DFSP generally inside the DFSP's domain. And they would have to call on that information. The case management solution at this point would have to have either integration into those platforms, or you would have to have some sort of process where you can request that information that may slow down an investigation itself. But that will be too slow for an interdiction. So interdictions are probably a little bit more, how should we say, shoot from the hip, based on the information that we know now, combined with the risk appetite of a particular organization, is we have done as much work as we can to score this transaction at first blush. Are we comfortable, given our risk profile, to let this transaction proceed? And that would be a different path through the platform, and we create an interim interdiction point straight out of the typology. The whole transaction doesn't have to be complete to interdict. You can interdict straight out of that typology that had a problem.
Yeah, no, I get that. And I think the challenge with interdiction is explainability. And if you get too deep into the system, you can't really explain why you're doing it, even though it's quite reasonable and was programmed in. It can unfortunately be not only unexplainable, but it can be non-deterministic. And you then have a problem with a customer trying to do something legitimately, a vendor or supplier at the end of the month who suddenly is getting a bunch of traffic. They left their phone at home, so they're using another phone they haven't used for 3 months, and all of a sudden they look fraudulent. But I think that what I guess I'm getting at is that as you hit the case management system, you've developed a theory in data that is related to a score. So leaving interdiction aside for a moment, having all of that theory with its parameterized data passed along to the account hosts to where they can study it and see that, yes, there was a compromised account. No, the PIN wasn't changed recently. However, the PIN is, that account is actually 3 months old and hasn't been used. What we want is to force a PIN reset now to interrupt the use of that account in future frauds or something like that. That's of course up to the account host as to how they would react. And what that gives rise to is, what is that bag of data and decisioning that the fraud management platform has done? Can that be passed off through the CMS? And would it be meaningful when it arrived at the account host side? Or is it just so internally studied that it wouldn't be valuable outside the platform? Does that make sense?
Can I just as on the to answer on the would it be understandable? I think Foley's just pulled up, and I think for his mind went to the same place. Is that that's plain language is what's being sent through, and that was what. So that's what's received the case management. That is the output that's being received. So
this is awesome.
So on the other end, once you've got that, if you then implemented a workflow, you could say, okay, if the account's been dormant in the last 3 months, and I'm just going to take the rule and just live with it and just move forward, then I want to kick off this internal workflow to do those things. This is, the whole process was structured that we give as much information as possible without overexposing customer data into the typology result. As the whole process was structured exactly for that purpose, to give operational insight to somebody without having to dive into all the detail.
Yeah, and then when they're in the case management system, they absolutely need access to all the other relevant data. They need to be able to replay what went on, and make decisions off that. So it has to be something that they can work with, and not structured from an internal perspective. So we have to map that back out. And that's
the cross-reference. The cross-reference is through the alias. It's not through internal stuff. And so when I see a flag here, well, one of your fields is ID. Is that the ID of the rule itself that is being triggered here, or where would I find the alias for the accounts in reference?
That would be in the account body. So the PAC 002 message at this point doesn't actually have the account information. So it makes it a little bit more complicated. But I do think that all of our body of history does have that information in it, but it is fully pseudonymized. So you don't get to see the account ID itself. You just get to see the pseudonym at this point. The intention is to never actually expose the underlying information unless it is to people who are authorized to see it and at a point in the process where it's relevant. In theory, you should be able to investigate yourself without knowing it's you.
Yes, and then what you'd want though at the end is to be sure that both counter participants have full access to the original IDs, because they were parties to the consequent quotation and quotation response, and therefore they are agreement participants. And so they have a right to know what aliases were utilized. And of course, on the receiving side, the creditor side, they have even more information than the sender would have in the event.
So for example, if you had to submit a report to a regulator for money laundering, that report would have to include the names of the people who are involved.
Yeah, absolutely.
That would be part of the obligation there.
And
also,
in many of these,
want to get back to your earlier comment around, I would actually build between the case management solution and the platform some kind of workflow orchestrator that manages business rules based on that first interpreted event. So for example, if you wanted to build a workflow event that says we've received suspicious indication about a customer's account, let's trigger a 2FA to that account now. So that you don't go through the case management solution to do that, but you go through some kind of interim business rules engine that can also notify the case management solution that there is an alert that must be investigated.
So Justus, this is the hybrid deployment assumption then, which is that the API is not limited to simply transaction flows. There could be other integration points between the account host and the fraud system. And it isn't purely through a CMS. It could be any variety of things. Do you have that kind of stuff in place now, or is there a strategy this for future development that would give you these extra reporting and notifications? Okay.
Yeah, it's future enhancement. So at the moment, we have built that green box in the middle there. We receive data, we perform an evaluation on that data, and that is abstracted to exactly the level of flexibility that we want it to be. Any data, any evaluation results in an output message to anywhere that says, we received your data, we did some stuff to it, here's what we found. and you could plug that into any sort of environment in exactly that, is as a utility to your ecosystem in that location.
That's awesome. So then you could actually develop out then this additional API between the account hosts in the community who are utilizing this system or are subject to it, and both through the CMS, but also directly from the system for notifications, where you could say, we just saw something, we recommend a 2FA on that account, but that's independent of the flagging and scoring that might go into the case management system. I see. Okay, that's great. Thank you.
And based on the channel design, everything can have different speed and performance levels, all the way from interdiction all the way to, you know, bulk that's done weekly, you know, etc. It's all built out to handle all those different possibilities.
This is incredible work, guys. Thanks for showing this.
Yeah, really nice work, guys.
Thank you very much.
Quick question. As you implement actual rules and typologies, how's it impacting performance?
Can we get back to you? So at the moment,
Yeah,
the
of course.
performance actually seems to be holding steady. The architecture is designed for parallelism. So in theory, your performance should scale, but there is an architecture or platform scale component that goes with that. So you have to throw some more resources in it to handle the additional load. But it's scaled based on the amount of, I suppose, processing cycles that we consume in order to do the work. But we are intending to do a sort of a shakedown cruise in our next PI, putting all of our rules and typology through a performance test and then letting you see the results. But at the moment, that's our turnaround times between processor steps. It's in definitely sub-second at least, but in the order of milliseconds.
I just want to jump in here and say we've run out of time, Justus. So if there are any other comments, I think Slack would be the best place to send that to for Justus to respond. But Justus, I'll give you a chance to wrap up your final thoughts.
That is it from us, and we look forward to coming back at the next PI and conclude our MVP. Thank you very much, everybody.
Excellent.
Thanks
Thanks so much, Justus.